This is Precalculus, section 4.4 notes. Today we're going to talk about exponential and logarithmic equations. First, an exponential equation is an equation with a variable in the exponent. And if we have our variable stuck up in our exponent, to solve for a variable in the exponent, we are going to change to log form, because that's how we can get that exponent, or how we can get that variable out of the exponent. Okay, so let's take a look at a couple of examples here. Skinnier here. All right, example number 1, we have 3 to the x power equals 26. We're trying to solve for x. X is stuck in the exponent. So our first move here is going to be to change form. So we're going to rewrite 3 to the x power equals 26 as a logarithmic equation. The base of the exponent becomes the base of the log. So this will be log base 3 of 26 equals, and then your exponent becomes what the log equation is equal to. And then now we can use our change of base formula, the COB, to evaluate log base 3 of 26. In our calculator, we're just going to type in log 26 divided by log 3. And that tells us that x is going to be equal to 2.9656. Number 2 is very similar. Once again, our exponent m is up in our exponent, so first step here again is going to be to change form. So this one is going to look like log base 4 of 18 equals, this time my exponent is m minus 6. I'm going to proceed the same way as before. I'm going to use the change of base formula to evaluate log base 4 of 18. So that's going to be log of 18 divided by log of 4. That's going to be equal to m minus 6. So when I do the change of base on my calculator, I get 2.0850. But that's equal to m minus 6. So now I have that last step in order to get m alone of adding 6 to both sides. So my final answer is m is going to be equal to 8.0850. And the last equation, again, my exponent is where my variable is, but before I change form on this one, I have to isolate the exponential term first. So that 6 that's being multiplied times e to the 5x, we need to undo that before we change form. So my first step here is going to be to divide both sides of the equation by 6. Now I'm going to have e to the 5x power equals 3.5. Now is the step where I am going to change form. If the base is e, then remember we're going to have log base e. That's a special logarithm. A log base e is a natural log. So this is going to be ln, which is log base e of 3.5 is equal to 5x. What's nice is, remember, our calculator does natural log, so we can just type in ln 3.5. That gives us 1.2528, and that's going to be equal to 5x. And then our last step is just to divide by 5. So we end up with x equals 0.2506. Number 4 and number 5 are a little bit more complicated because these are trinomials. In number 4, the first thing that I notice is that we have a GCF. Each term in this trinomial has e to the x in it. So the first thing I'm going to do is I'm going to factor out that e to the x. That's going to leave me with x squared plus 2x minus 15 equals 0. Now that trinomial is an easy factor. So again, I'm just going to carry my e to the x down. The factors of negative 15 that add to make 2 are going to be positive 5 and negative 3. So I'm going to have x plus 5 times x minus 3 equals 0. And now I'm done factoring. So now I'm going to use the zero product property, and I'm going to set each of my factors equal to 0 so that I can solve. So I'll say e to the x equals 0, x plus 5 equals 0, and x minus 3 equals 0. And now I can go ahead and solve. So this one gives me x equals 3 as a solution. This one gives me x equals negative 5 as a solution. And then my last one, this is asking e to the what power makes 0? Well, if you think about that, e to the first power would be e to the 0 power would be 1. E to the negative 1 would be 1 over e. Is there ever any exponent that will turn a positive base into 0? The answer is no. So this one gives us no solution. So our two answers are x equals negative 5 and x equals positive 3. Example number 5 is kind of similar, but in this one what we have to think about is the power of a power property in reverse. This is a trinomial. We want to make it look like a squared term and an x term and a constant term. So we can see that our middle term is 7e to the x power. The problem is the first term. So what we have to do is we have to kind of decompose this power of a power. Remember, when we have a power of a power, we're multiplying exponents. So that e to the 2x we could really write as e to the x squared minus 7 times e to the x minus 18 equals 0. So now it's like our variable, instead of being x squared and negative 7x and negative 18, our variable portion here of our equation is just e to the x power. But this is an easy factor, right? We're looking for two numbers that multiply to make negative 18 and add to make negative 7. Those two numbers are going to be negative 9 and positive 2. But instead of x minus 9 and x plus 2, it's just going to be e to the x minus 9 and e to the x plus 2. And now I can use the zero product property to solve. So this equation is going to be e to the x equals 9, and this equation is going to be e to the x equals negative 2. Well, e to the x equals 9. Now I'm back to, here's an exponential equation, and my exponent is where my variable is. If I want to get that variable out of the exponent, I need to change form. So once again, the base of my exponent is e, which means it's going to be a log base e. That's an ln. So ln of 9 is going to be what x is equal to. And then I can grab my calculator. Natural log of 9 is 2.1972. My other equation, e to the x equals negative 2, I could change form, right? Then this would become ln of negative 2 equals x. But there's a problem here, right? You can't take the log of a negative number. We've talked about that before. And this is because if you think about the equation in exponential form, this is saying e to some power equals negative 2. Okay, we just talked about this a second ago. E to the first power is e. E to the 0 power is 1. E to the negative 1 power is 1 over e. Remember, negative exponents make fractions. So there is no exponent that could turn a positive base into a negative number. Therefore, this equation has no solution. So we only have the one solution, x equals 2.1972. Now we're going to transition to logarithmic equations. A logarithmic equation is an equation that contains a log of a variable. To solve our equation, we have to remember that somewhere in the process of solving, we're going to be rewriting our equation as an exponent. Just like when we were trying to solve an exponential equation, we changed to log form. If we're solving a logarithmic equation, we're probably going to be changing to exponent form. Let's take a look at our first example. Example number 1, we have log base 3 of 2x minus 1 equals 4. Well, if my variable is inside of my log, my first step is going to be to change form. I'm going to begin with the base. If the base of my log is 3, the base of my exponent will be 3. So 3, the power is always on the other side of the equal sign. 3 to the 4th power equals 2x minus 1. Now this is an easy algebraic equation to solve. 3 to the 4th power is 81. So I have 81 equals 2x minus 1. I'm going to add 1 to both sides. So I have 82 equals 2x. And then I'm going to divide by 2, and I get x equals 41. In example number 2, this is similar, except I have an extra step because I have a 5 that's being multiplied times my log. So before I change form, the first thing I'm going to do is divide by 5. That's going to give me natural log of x plus 3 is equal to 12 divided by 5 is 2.4. Now I am going to change form. If I have a natural log, then I have a base of e. So this is going to be e to the 2.4 power equals what's inside my log, which is x plus 3. I can evaluate e to the 2.4 power on my calculator. That's just 11.0232 is equal to x plus 3. So then my final step will be to subtract 3 from both sides. So I get an answer of x equals 8.0232. My last example, I'm going to need a little bit more space, so I'm going to go ahead and rewrite this problem on another page here. I have log of x plus 2 plus log of x minus 1 equals 1. The first problem with this equation is that I have 2 logs. So I need to condense these 2 logs together. But that's okay because we know our laws of logarithms. 2 logs that are being added will condense to multiplication inside of the log. So this is going to become log of x plus 2 times x minus 1 equals 1. Okay, and now that I've written this as a logarithmic equation, now I can go ahead and I can change form. Now remember, if you don't see a base, that means that your log has a little invisible base of 10. So when we change form, we begin with the base. It's going to be 10. My exponent is on the other side of the equal sign, so 10 to the 1st power equals x plus 2 times x minus 1. Well, 10 to the 1st power is just 10. And I can go ahead and I can FOIL on the right side. X plus 2 times x minus 1 gives me x squared plus x minus 2. Now, in order to solve this, I'm going to have to set it equal to 0. So I'm going to move that 10 over to the other side of the equal sign. That's going to give me 0 equals x squared plus x minus 12. Now I can refactor. I have an easy factor here. 2 numbers that multiply to make negative 12 and add to be 1 are going to be x minus 4 times x plus 3, which gives me 2 solutions. When I set them equal to 0, this one gives me x equals 4, and this one gives me x equals 3. Oops, I apologize. I have my signs wrong. Let's back up a step here. Sorry about that. My signs should be x plus 4x minus 3 because I'm trying to make a positive one in the middle. I was a step ahead of myself there. So my 2 solutions are x equals negative 4 and x equals positive 3. Now, we have to be very careful because we have a logarithmic equation. We have to plug these back in and check them. And the problem is when you plug x equals negative 4 back in, it does not work because this would give you log of negative 4 plus 2 plus log of negative 4 minus 1 equals 1. This ends up being log of negative 2 plus log of negative 5. And as we know, we can't take the log of a negative number. So this gives me no solution, and I